Hi, I'm Eric, and this is my hand. And so today we're going to be looking at two little parts of two real FRQs from the actual AP Calculus exam. So um, the first question I'm going to be using is 2009 Form B. It's question number 3. And then on the other side of this paper, I'm going to be working out part D to 2008 number 6. So let's begin, shall we? So, um, for this question, we have this piecewise function that's split off one side from the other side. So it says that we have a continuous function because it is continuous. There are no discontinuities. So it's defined on the entire closed interval. We know that there is an actual line segment. It's defined as a line segment here, and then a curve, some curve. So that's pretty much all the information that we need for now. So the part that relates to limits is where it says, is f differentiable at x equals 0? And this is part A. So we're going to use the definition of the derivative with one-sided limits to justify our answer. Hooray! So the limit definition of a derivative, in case any of you forgot, is where we go the limit as some random variable other than x. For the purposes of this demonstration, we're going to call it h. That goes to 0. We're going to say that the function, when it's defined at h, minus the function at 0 all the way over that h is going to be our little limit thing. So this is our derivative. So we're going to be making this a one-sided limit. So for the first one, we're going to make it a minus. So this is going to be from the left. So that means that we're going to be looking at what slope the function f gets to arbitrarily close to x equals 0. So because it's a line segment, and I've got the answer key right here, so you can have I've got your back, okay? So the line segment here says that we can probably pretty easily define its slope. So what we're going to do for this part is maybe draw a separate triangle if you're not okay with writing on the diagram. I don't know how you do things. Do you okay? So we know that the change in y is 2, so we're going to write 2, and then the change in x is 3. It's a positive 3. Even if it goes into the negative part of the x-axis, it's a positive change in 3. That's magnitude. So we're looking at magnitude, not distance. Backwards or forward, it doesn't matter. So anyways, we know that our slope is going to be the change in y over change in x. So that's 2 over 3. So that means that this one-sided limit here, this derivative, this slope, that's going to be equal to 2 over 3. So great, we have half of our answer so far. So now what we're going to do is make another limit. So we're going to make the same limit, but this time we're going to put a little plus there. And let's see. Great, we did it. Yay. So for this one, it's a little bit more difficult in terms of how you're supposed to come up with the answer. Because you're not able to figure out a specific answer that you're gonna come onto here. So let's look at this. So we don't know a whole lot about this curve. Okay, we don't know the equation that the curve is supposed to follow. But what we do know is that as the curve gets arbitrarily close to 0, it looks like it's negative. See it? Yeah, that's all we know. It's just, yeah, yep. It looks like it's negative. And you can actually go off of the graph roughly when you're actually doing the test. Sometimes they're not exactly accurate, but for the most part, you should be able to look at a graph and say, like, that's the general information that you need, okay? So for this, you can just say, hey, the slope is it's less than 0. Congrats. So it's definitely not 2/3, and that's all that the judges or whoever's arbitrating your answers actually cares about. So what you're gonna look at here is that you also need to justify. So you do get 1 point for setting up the difference quotients, but you also need to do an explanation. So in like words or whatever. So we're gonna write because. Always sort of sentence out with because, it's great. Because the two limits disagree, f is not differentiable at x equals 0. And you can write something roughly like that. Doesn't really matter. I mean, whatever works for you, mate, okay? So, yeah. And then this is the answer bank that I'm looking at here. This is, again, 2009, number 3. So, this is from Form B, by the way. So, the limit part of this question, which relates to chapter 1, which is why I'm doing this, your answers are divided up into 2 points. So you get 1 point for the difference quotient and another for the answer with justification. And yeah, they just wrote it less than 0. Incredible, right? Yeah, great.